Okay, so far we have added and subtracted radicals. We've multiplied radicals. Next, we're going to divide radical expressions. And nope, the fun will never stop. These things are fun. Okay, first, can we all agree that anything divided by itself equals 1? 5 divided by 5 equals 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 1. Cat divided by cat equals 1. Right? We all agree with that? Can we also agree that any number, when you multiply it by 1, it just stays that same number? So 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1 equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? 4/5 times 1 is 4/5. Pi times 1 is pi. Cat times 1 is cat. That makes sense? So once we all understand this, then we're really ready to divide radical expressions. And we know we can't have a radical, one of these little dudes, in the bottom, right? We all know that? Okay, so that means we need to get rid of that. Well, can I just multiply, since anything divided by itself is 1, and I can multiply anything by 1 and it's still itself, can I just multiply top and bottom by radical 10? Now I have radical 10 times radical 10, that equals 10. Radical 15 times radical 10 is radical 150. And then I can simplify this. It's radical 25, radical 6. So that means our answer is going to be 5 radical 6 over 10. Well, I can reduce the 5 of the 10. It's going to be radical 6, or 1 radical 6 over 2. Make sense? Easy beans? Okay, let's try these two. So I can multiply, I'm going to change color here, the top and the bottom by radical 2, right? So this on the top, we're going to have 5 radical 2. And on the bottom, I have radical 2 times radical 2. That's just 2. And over here, can multiply the top and bottom by radical 3. Radical 3 times radical 5 is radical 15. Radical 3 times radical 3 is 3. Right? Because the square undoes the square root. Try these yourself. What are we going to multiply the top one by? We're going to multiply top and bottom by radical 15, right? Radical 15 times radical 15 is 15. 25 times 15 is a big number. Let me get my little handy-dandy calculator here. 375. 375 divided by 25 is 15. So that becomes radical 25, radical 15. So radical 25 becomes 5, radical 15 over 15. When we reduce it, take the 5 out here, this will become a 1, and this will become a 3. So divide both of them by 3. Make sense? So there's that answer. Oh, yeah. I can erase this a little bit. Eraser. Okay. Radical 2 divided by radical 3. So we're going to multiply the top and the bottom by radical 3. 2 times 3 is radical 6 over 3. That one was pretty easy, huh? But what happens if there's a binomial in the numerator? Since it's just the radical we're trying to get rid of, and this is a multiplication problem, can we just go 3 radical 5 minus radical 2 over 2 radical 7? Can we just multiply the top and the bottom by radical 7? Because that's the only thing we have to get rid of, right? So if I put this into parentheses and I multiply both of these by radical 7, I'm going to get 3. 7 times 5 is radical 35. 7 times 2, radical minus 14 over, let's see, 2, radical 7 times radical 7 is 7, right? So total we got 3 radical 35 minus radical 14 over 2 times 7 is 14. Does that make sense? Okay, let's try another one. This one only has the radical in the bottom, so we're going to have to distribute that radical to both terms on the top, right? So we've got 5 plus 5 radical 5. And I'm going to put that in parentheses so I don't forget to get to both of them. And radical 18. So I'm going to multiply the top by radical 18. And I'm going to multiply the bottom by radical 18, right? This is going to distribute, going in reverse. 5 times radical 18 is 5 radical 18. Plus 5, let's see, 5 times 18 is, 90. 5 radical 90 over radical 18 times radical 18 is 18, right? Now, is there a perfect square that could come out of either this, this 18 or this 90? Well, sure there is. So we got 5. I could say that this is radical 9 times radical 2, right, for the 18. Plus 5, let's say it's radical 9 times radical 10 for 90 over 18. I'm going to run out of room here. We know radical 9 is 3. 5 times 3, should I change colors? 5 times 3 is 15 radical 2. 5 times 3 here, that's 15 radical 10 over 18. Can we reduce this? Okay, I moved everything up so we'd have a little more room here. Because these 15s and this 18, we can still divide all of those by 3, right? Radical 18, yeah, sure enough. So 15 divided by 3 is 5 radical 2 plus 15 divided by 3 is 5 radical 10. 18 divided by 3 is 6. Now it is totally simplified. Oh, that was like work. Now what happens if there's a binomial in the numerator? That's what we were doing before too. No, this one has... Okay, good. So we got 3 plus radical 2 over 4 radical 15. Remember what we said before? We only have to put the radical up, right? So radical 15, radical 15. 3 radical 15 plus 2 times 15 is 30. And on the bottom we got 4 times 15, right? There's no perfect squares that come out of 15 or 30 that are factors, so we're just going to 3 radical 15. Oh, my dog is snoring. I don't know if you can hear him. What was this one? My dog is dreaming. Over 60. Right? Yep, that's it. But now, what happens if there's a binomial in the denominator? It's on the bottom. We're going to have to multiply the 4 and the radical 5 by everything, right? because we can't just split up the binomial. So we got 3, 4 plus radical 5, and we're going to have to multiply both of them by 4 plus radical 5, 4 plus radical 5, right? Does that make sense to you? Oh wait, no, we're going to plus it, we're going to minus it, because we're going to want to end up with a perfect square binomial down here. So 3 times 4 is 12 minus 3 square root of 5. And on the bottom, we have 4 plus radical 5 times 4 minus radical 5. Do you remember the difference of two squares? So this is going to be a squared, which is 16, minus b squared. Square root of 5 times the square root of 5 is 5. So we ended up with what's 16 minus 5? 12 minus 3 square root of 5 over 11. Does that make sense to you? We changed this to a negative so that we would end up with the difference of two squares. Let's try another one. Okay, this one is already a negative, so what do you think we're going to do with it? Square root of 5 minus square root of 2. I'm going to change that to a positive, right? Square root of 5 plus square root of 2 over square root of 5 plus square root of 2. 2 times the square root of 5 is 2 square root of 5. 2 times square root of 2 is 2 square root of 2. That's nothing tricky there. Okay, now we're going to go square root of 5 squared is 5. There's a negative here because there's a negative times a positive. Square root of 2 times square root of 2 is 2. We end up with 2 square root of 5 plus 2 square root of 2 over 5 minus 2 is 3. Make sense? Just change the sign. Okay, last one. 3 over 2 minus square root of 5. So what are we going to multiply these both by, the top and the bottom? 2 plus square root of 5. 2 plus square root of 5. 3 times 2 is 6. 3 times plus 3 square root of 5, right? 2 squared is 4 minus square root of 5 squared is 5. What's 4 minus 5? 4 minus 5 is negative 1. So I could put 6 plus 3 square root of 5 over negative 1. Or I could just say negative 6 plus 3 square root of 5. Make sense? Ready for a little bit of practice? Please get a hold of me. Call me, email, send a pigeon, do something. If you have questions, let me know. Okay? Thanks.